Hey there, today's video is going to be about how to handle AN fittings. Now I'm still in the process of building this oil filter relocator where the oil filter and oil cooler are going to be mounted this way, and then I need AN fittings to go to the original oil filter position. And that's the kind of AN fitting I'm talking about. So those are aluminum fittings that they're not crimp fittings, they're reusable fittings that you tighten on a hose. Now that's the easy part. Those fittings are made with a 37-degree taper that you see here, and this is what makes them tight to fluids. And those fittings always come with the female nut on it. For some reason, it's very hard to find them with a male adapter directly, well, with a male thread directly on. So you often need that kind of adapter. So this is a jig adapter that goes on the flare side here, and on this side, well, you could as well have NPT or another 37-degree flare, but in this case you need the same kind of flare in the bore you're going to screw it in. So that kind of taper in the bottom of the chamfer. So I figured out why not try those O-ring bus adapters where you have again a straight thread. This is an AN8 fitting, so it's 3/4 of an inch 16 TPI thread. I'm a metric guy, but hey. So, and this is a straight thread, so it's not the thread that's going to do the oil tightness, and it's not the flare either, because you don't have that kind of flare here. So it's an O-ring that's just mounted here. Now you could think it's going to be much easier because you don't need a chamfer or whatever, and you're just going to screw that on the flat. Well done, that's not how it's supposed to work. And it's not supposed to work just in a simple corner bore either. You just can't make a corner bore that's roughly the diameter of the O-ring and with the adequate depth to compress the O-ring. You probably could and it might work, but that's not how it's supposed to. So the correct way is you need a dual chamfer. Well, first chamfer depends. There's a proper SAE spec for that. First chamfer in the case of AN8 is a 15-degree relative to the thread axis, and then at a specified depth and specified outer diameter, and then a 45-degree chamfer that goes to the minor diameter of the thread. And it is the first, well, that's then a 30-degree chamfer that compresses the O-ring against the ID of the adapter as you screw it in. So I'm not planning on buying specific, they exist. Actually, Aidan Booth made a nice video about that. I'm not planning on buying specific form cutter for that, so I'm going to try that in a lathe. Now finally, after some tuning of the bore and thread diameters, I found the proper parameters to fit the adapter. Now you can see what the two chamfer job looks like. So this is the first one that's 30 degrees across, and then the second chamfer that's 45 degrees or 90 degrees across. Yeah, the second one is really just the thread end to chamfer. This is what happens when you screw in the adapter. You will see that the O-ring fits just in chamfer. It's being compressed. You can feel it squeezing as you progress in the thread. It's being squeezed in the chamfer against the bore, and then you're supposed to tighten the nut against your workpiece, and so this way the tightening torque does not rely on compressing the O-ring, which would be totally unacceptable. Alright, now I've got my part dialed in and ready to go. It's off center by 10 millimeters for this side, and then the other one is going to be off center by 20 millimeters. Well, I had to flip 3 jaws out of 4, and this way it's pretty well balanced, seems to do okay above 500 RPM, and we'll see when we flip that and increase the offset. Now fingers crossed. Those aluminum inserts are just wonderful. Now this is another part that I made a while ago. It's supposed to replace the original bell type old filter housing that has that kind of bell shape, and you have that paper filter element inside, and you just replace the element, not the entire filter body. And it was plastic, so I couldn't modify it in any way. So this is the old pickup adapter that I made. Now the difficult thing with that adapter, you can probably see it here, it is an asymmetrical hydraulic buttress thread. Well, because you have up to three and a little bit more bar of oil pressure pushing on this entire surface, which is quite a lot of force actually on a plastic part. So that's probably why they went with that kind of thread, which has a much higher resistance in this direction because it pushes on the straight face, and then you have a relief face on the other side that's not working. Then you have an O-ring groove there and an O-ring groove chamfer, O-ring chamfer here, and this one seals the adapter from the casing, and this one seals the two oil circuits. This has to be the output of the oil pump, and this has to be the output to the oil galleys. So we're going to do something here, and the two ports that we machine on the other adapter and the two ports on this one will be connected by an 8 hose to relocate the oil filter. This way I will be able to mount an out cooler. That is the entire reason for all this mess. This last hole is going to be slightly different because I misplaced it a while ago in the center of this OD without knowing the size of the fittings, and they're going to be very close to each other even this way, and that's just because of the geometry of the oil ports, and I can't do anything about that. But I'm going to drill slightly off center of this hole, and the thread is probably going to miss a sector because it's going to be borderline with this is going to be tangent with the major diameter, but I'm good with that as long as it doesn't impart the chamfer of the O-ring. So that's all I need. I can see the original hole is stopping just before the O-ring chamfer. It's going to imprint through the thread, but that's fine as long as it can seal in this chamfer.